name's Colin Page with Tar Sands Recovery Limited. Myself and my dad, Pat Page, invented this system in 1997. What we do is we use a closed loop water system with a couple of reagents in the water to break the bond between the dirty sand and oil. We end up with clean sand and resalable oil at the end. At the end of that 50-foot conveyor is a screening plant, and that's to take out all the undesirables, the large gravel, any junk that comes through your system from stinging tanks. From there, the sand falls out the bottom of that screening plant into that sand screw. That's the initial introduction of the dirty sand into our water system. So all of our surfactants and reagents are in the water. It slurries in that popper for roughly 5 to 10 minutes, and then it's augered up the end and metered out into our vessel, which we'll go inside now and we'll have a look at the vessel from there. This is our introduction from the sand screw outside the building. Here we use a water jet and a spray bar to slurry our sand back. It drops through this grating into a set of venturis, and those venturis introduce our sand into our vessel. Now the sand is coming in the bottom of here, and as you can see, there's oil floating off the top. The oil that floats off the top of here goes down into our oil recovery tank. The oil gets skimmed off the top. The water goes to another common tank, which is then pumped to our big settling tank for reheating and some settling overnight. All but maybe 0.25% of the oil from our slurry is taken off at this vessel. This vessel runs at about 58 PSI. It's very low pressure. We use a temperature of 50 Celsius. We try to be no hotter than 50, no colder than 45. What this does is breaks our bond on our sand, washes it, oil recovers off the top, floats out into that common tank, and the sand goes out the other end as clean sand. We keep this water at about 50 Celsius so the oil stays buoyant, and when we get enough oil in this tank for a load, we just have a vac truck come in and pull a load off and take it directly to sales. And the water from here gets recovered back again to our main settling and reheating tank. Our clean sand comes out the bottom of this vessel down here, out this 4-inch pipe. From there, our sand is clean, goes out the end of that. Sand comes off the sand screw. It's at about 15% water volume. It drops onto this dewatering screen, which drops it down to about between 5 to down to 2, as low as 2% water. Here we are at the clean sand end. As you can see, just by the eye, there's a huge difference. This sand in my left hand here, this sand is good for processing in lots of different secondary markets. In the industry, it's known as flour silica. It's extremely fine. It's about a 60 micron, which makes it really good for processing glass and microchips and different things like that. Most systems now are using up to 100 Celsius water, 95 to 100. Most of them use steam. Any other systems use 2,000 to 3,000 PSI as far as the washing pressures. We've designed this system to use gravity and way less pressure, more of a gentle washing. We seem to get a better recovery. We get 100% hydrocarbon because of the low PSI and our washing action in our vessel. One 10-horse pump runs the whole system. and we have a 3 horsepower pump to return our water back to our heating and settling tank. And that's the only systems we have. Air compressor to run some of the instrumentation. So very low use in as far as energy consumption. So if you compare, 2,000 PSI to 58 pounds, we're huge there. And the temperature difference is also huge when the calories it takes to go from 50 Celsius, which is about your household hot water heater, to 100 Celsius, which is boiling and above to get to steam. Our efficiencies as far as economics go are leaps and bounds ahead of the other systems out there. We don't use any makeup water in this system. Only water we have to add to our process is what we lose to evaporation, which is very minimal. On a month-to-month basis, on a system like this that cleans 16 cubes an hour, we maybe have to add 4,000 gallons of new water a month, which is very, very small, 2 water truck loads, and we may not lose that depending on temperatures. Obviously, outside temperature makes a big difference in everything, but it's a complete closed loop system, so there's no disposal water at all and very little makeup water. The oil that we recover, it can go right to a sales line. The clays and the fines and the water content are below a 0.5% cut, so it can go directly into a sales line. Most of the heavy metals come out with the water. The only disposal that we do have is our clay fines, which are less than 0.1% total volume of product here. We add our reagents with the water. They're water soluble, so they stay with the water. We've done it used to be called the fish test. Now it's a microtox test. We've met all the criteria. Within 14 days of putting our product in the water, that water can go right back into a creek or a river. There's absolutely no microtox problem there. With this system right now, we can do 16 cubic meters an hour with this system in place. We've had it engineered to upscale. We can go to, basically, sky's the limit. We have a vessel designed right now that would do 56 cubic meters an hour. We don't have one built, but we do have the engineered drawings for it. From there, it becomes more of a factor of dimensions of hauling. We're trying to keep everything inside of highway limits as far as weight and dimension goes, so they're easy to transport and move. All the other equipment, the sand screws and the conveyor hoppers, that can all be upscaled.